There we go. So again, we're revisiting the last problem from last class where we did law of cosines to figure out some information. We're also going to throw law of sines on top of that to get all of the information out of the triangle pretty easily. So I've got my setup here. My unknown side is x. Remember, A is our unknown. Unknown. B and C are known sides, and A is the angle between known sides. So our unknown side squared is equal to the sum of the squares of our known sides minus 2 times their product times the cosine of the angle between them, which here is 46.5 degrees. It's important that we're doing this in degrees so that when we go to punch it into our calculator, we actually get out the right number and not something weird. Plug this into my calculator. I get that x squared is equal to 10.5 squared plus 18 squared minus 2 times 10.5 times 18 times cosine of 46.5 degrees. I get that x squared is approximately 174. I like to round to note whole numbers. It only rounds to 174.1, so rounding down to a whole number is fine. And so square rooting both sides, I get x, let's see, square root of 174. That's nice. X is approximately 13. Actually, x equals 13.2, which it might be useful to carry that decimal point of accuracy so that everything adds up. But you can leave it as a whole number. I prefer whole numbers anyways. So we have this missing side here, 13. I'll go ahead and put the 0.2 on it just to be safe. And now I don't have to use law of cosines to figure out all the rest of my information. I just need law of sines, which is arguably a lot easier because it's just 2 fractions and I rearrange. So I've got a pair here, and I can figure out either of the other angles just by picking their opposite sides. I'm going to call this angle theta. I'm going to call this angle phi. So remember it says sine angle A over side A equals sine angle B over side B equals sine angle C over side C. It doesn't matter what I call A, B, and C. What's most useful here is that I have a pair of information and I plug my unknown into the other side of the fraction for whatever it is. So my known information pair here is this angle of 46.5 degrees and the side length of 13.2, whatever the unit is. So I have that sine of 46.5 degrees divided by 13.2 is equal to, do we want to solve for theta or phi first? It doesn't matter which one. Theta? All right. So I'm doing sine of theta. And then what is the length of the side opposite that? 18. Then solving for theta, I get that theta is equal to the inverse sine of 46.5 degrees divided by 13.2. Punch that in my calculator. Inverse sine of 46.5 degrees divided by 13.2. And I get 3.2. Seems way too small. Oh, yeah, and then times 18. So there should be an 18 there too. So I'm taking the inverse sine of 18. Sine there. Okay. Yeah. Cross off that 18, take the inverse sine. So let me try that again. 18 sine 46.5 divided by 13.2. That makes a lot more sense. I get 81.6. 81.6 degrees. That makes a lot more sense. So I've got 81.6 degrees here. And then I can solve again for my final missing angle. Pretty easy. I just take, and instead of having sine theta over 18, I'm doing sine phi over its opposite side of 10.5. Multiply the 10.5 over, and take the inverse sine on both sides. So this is going to be 15, or not 15, 10.5, my bad. 10.5. And that's all I have to change. So I can go in here and change this to, how do I insert all this? And delete and 10.5. And I get an angle of 35.2 degrees. Did anyone else get that angle? Did anyone else put it in their calculator? If not, that's fine. But that I get now that angle phi is 35.2 degrees. And then how do I check to make sure all of this works out nicely? I should add them together and make sure I get 180. For some reason, it looks like it's not going to add up to 180, but let's check. I don't think it will, so I'm trying to figure out what's not right here. 46.5 plus 81.6 plus 35.2. I get 163, so I'm missing something somewhere. That's fine, we'll just try again. What information did we already have? We figured out just 13.2 using law of cosines. So I had that. 10.5 and 18 were already given to us. So something about these two angles was off. So I just need to check my work there. I probably made just some small error somewhere. I need to check it. So that 13.2 was good. That was from law of cosines. I can then say sine of 46.5 degrees divided by 13.2 equals, this was theta and phi, sine theta divided by 10.5. So multiply both sides by 10.5. Take the inverse sine. So I get theta is equal to the inverse sine of 10.5 sine of 46.5 degrees over 13.2. And let's see if I can get this in my calculator correctly this time. 10.5 times sine of 46.5 divided by 13.2. I get 35.2 again. Oh, I think the issue was I used 10.5 instead of 18. I should have used 18. So I think that might be where my issue came from. We'll try it. Figure that one out. Alright, so that was for theta. Now for solving for phi, I have sine of 46.5 degrees divided by 13.2 equals sine of phi over 18. So phi is equal to the inverse sine of 18 sine 46.5 degrees divided by 13.2. Inverse sine of 18 sine 46.5 divided by 13.2. And I also get 81.6 again. So it might be that this side length is actually wrong. So I need to check that as well. It's always important to check your answers to make sure that they have some sort of accuracy. Mine is off, so I want to figure out what the issue is here. So it might have been an issue with me doing a lot of cosines. I might have skipped something. So I was given these two sides. Let me double check that those were the correct sides. 46.5, 10.5, and 18. Yes. Okay. So x squared, we're going to say this was x, equals 10.5 squared plus 18 squared minus 2 times 10.5 times 18 cosine of 46.5 degrees. And let's check that. 10.5 squared plus 18 squared minus 2 times 10.5 times 18 cosine 46.5. I get 174. X squared equals 174. So x equals the square root of that. Square root of 174 equals, 13.2. So I'm not sure why we're off by a total of 11 degrees. I don't think it's a rounding error. Does anyone spot any problems in my work? Because I can't find it and it's driving me crazy now. This part I'm pretty confident with. That came out correctly. I don't know why the other two parts wouldn't be correct. Well, if you can figure out the error and present it to me, I'll give you 5 bonus points on your test. How about that? So take this problem home, work on it, try to derive out the full solution. Don't just use ChatGPT. That's lame. Like, show all of your work, and if you can figure out where I made the error, like actually point out where the error was, then I'll give you some bonus points. Everyone's taking a picture of the board now. Everyone wants bonus points.
Okay. Got you, Camille.
Alright, everyone got a picture of the board that needs it? Again, this is recorded so you can watch back as well. Alright. That was a great way to waste 20 minutes of your time. I apologize for that. I apologize dearly for that. I don't know what happened, but hopefully someone figures it out. I'll probably go back to my office and work on this as soon as class is over. So now we want to talk about how this applies to, for instance, navigation. This is where it's really useful. For instance, if I want to talk about I'm traveling, say, north with 10 degrees east, so that's written north 10 degrees east, that means I go 10 degrees to the right from the y-axis. So I make an angle of 10 degrees there. Or if I say south 20 degrees west, so this is south 20 degrees west, I'm going to the west at an angle of 20 degrees. It's important to remember your cardinal directions: north, east, south, and west. So then this would be north x degrees east, south x degrees east would be over here, south x degrees west, and north x degrees west. So the problem for this that I have for y'all is we're heading north 70 degrees west for 30 miles. That's our first trip. Our second trip, on top of that, is then we go north 10 degrees east for 50 miles. And so the questions are, what is my angle relative to where I started? Angle from start. And another question is, how far am I from the start? And it's not just 30 plus 50 because it's a triangle, so it's going to be less than that. How far from start? So we definitely want to draw this out. So I start somewhere. I'm going to draw a little coordinate plane for it. I'm going north at 70 degrees west. So this is 70 degrees. And I go for 30 miles. I then go north at 10 degrees east. So there's my point there. I go north at 10 degrees east for 50 miles. So my new coordinate plane, and I can draw it a little bigger. This is 10 degrees. And now the question is, what angle am I relative to home? And how far from home am I? So I want to figure out this line. And I want to figure out this angle, theta, and this side x. So we have to be a little clever about how we go about this because we don't have all the information that we need. We have a good bit of it, but not all of it. One thing that we have to remember from high school trig is that if I have two parallel lines and some line that runs through them, these acute angles are going to be the same, and the obtuse angles are going to be the same. Maybe I'll hold this flat. So since both of these coordinate grids are parallel to each other, they both face due north, right? This is north, this is north. There's a true north, and those face that. Then this line here, if this is a 70-degree angle, then it also forms a 70-degree angle here, maybe here. All right, if this is 20, then this one is going to be 20, and this one is going to be 70. The corresponding angles are on opposite sides of the line. So if 20 is on this side of the line, it's going to be on the opposite side of the line there. 70 is on this side of the line, it's going to be on the opposite side of the line there. Good enough. And then I have the rest of this angle right here. It's pretty easy to figure that out. This makes a 90-degree angle because it's the x and y axis. That makes a 90-degree angle. So if this is 10 degrees, how much is this? 80. So I've got a little bit of information there. I've got 30, I've got 50, and the angle between them is 20 plus 80, which is 100. And now I've got this set up for law of cosines. I've got two known sides and an angle between them. And here's x. All right. I'll keep it there actually. So law of cosine says that my unknown side squared is equal to the sum of these squares, 30 squared plus 50 squared, minus 2 times their product, and the angle between them, which is 100. So I've got 30 squared plus 50 squared minus 2 times 30 times 50, and then cosine of 100. All right. I wrote it down wrong in my notes. That's good. That's fine. All right. So if anyone else did it with me, I got that x squared is 3,920.9 miles. That's x squared. Did anyone else get that? Good. Cool. Then I just take the square root, and I get, let's see, square root of 3920.9. I get x is 62.6 miles. Does that answer make sense? Yes. It's shorter than the sum of these, which is 80, but it's longer than either of them individually. Since it looks like it's the hypotenuse of the triangle, those are the conditions that we expect to have met. Cool. So we'll draw that in our big triangle here. This is 62.6. And now how can I find this angle here? Law of sines, right? I have a pair. I just derived out that pair. And I have another pair now. So I can use law of sines. So I have sine of 100 degrees over the corresponding side of 62.6 equals sine of my angle theta divided by the corresponding side, which is 30. Multiply 30 over here, I get 30 sine of 100 degrees divided by 62.6 equals sine of theta. And I just go over to the other side. I thought I had figured out the problem from the last one, but I don't think I did. Maybe I did actually. We'll figure it out. Okay, so then I get theta equals the inverse sine of 30 sine 100 degrees divided by 62.6. All right. plug that into my calculator. So I've got inverse sine of 30 sine 100 divided by 62.6. And I got an angle of 28.16. That looks about right. This angle right here should be less than 70 degrees because it was 70 degrees, but this line cuts it a little bit, and that makes sense. It'd be 18.16 less than 70, so there we go. We could then find that last angle, 180 minus 100 minus 28.16. And I get 51.84 degrees. And that makes sense. Again, this whole angle was 70 degrees, and I've chopped it because I don't come in equal to this since I'm at an angle right there. So I cut it out some. This is a pretty complicated problem. It involves not only the knowledge of this, the knowledge of drawing your problem, the knowledge that all these angles equal 180, knowledge of law of cosines, and knowledge of law of sines. It requires all that knowledge together and expects you to be able to put it together. So this is a really complicated example. Go over it a few times in your notes. Make sure that you get it pretty well. I also think I might have figured out the problem with the first example. Why are you shaking your head? You don't want me to say? You can still get the bonus points if you find the error. I believe it has to do with coterminal angles. So that might be a slight hint there. You can still get the bonus points if you figure it out and actually point out the problem, write it up, and bring it back to me. You can do it tomorrow, or you can bring it back to me Monday. Give you some more time to do it. So. Any questions about anything that we've done here right now? What is there useful for you all? At the end of the chapter, it gives you a reference guide for some values of sine, cosine, and tangent that are pretty useful. We'll talk about those real quick, just so y'all have those. Is everyone good for me to erase what's on the board right now? So remember yesterday we talked about trig functions in terms of coordinate geometry. We talked about how we can derive sine squared x plus cosine squared x equals 1 from that, and how sine is y over r, cosine is x over r, tangent is y over x, stuff like that. So we're going to do that a little bit. This is more so foreshadowing for doing the unit circle. But we'll look at some important things. First, just starting out in the first quadrant. So that's 45 degrees. Here's 30 degrees. Here's 60 degrees. Here's 0. And here's 90 degrees. All right. Instead of having to go through for these, what we call significant angles, and figure out the trig functions, or not the trig functions, but the relationship between these degree measures and radian measures, once we do the unit circle enough, you'll just remember them. So this is 0 degrees. This is also 0 radian. if a full circle is 2 pi radian, this is a quarter circle, so 2 pi divided by 4 is pi over 2. So it's pi over 2 radian. Then half of that is pi over 4 radian. This will come out to be pi over 3 radian, and this will come out to be pi over 6 radian. That's a 6 there. It makes sense. 60 is twice this, so the radians should be double each other. And then this is just halfway in between these points, so that's how you could think of it that way as well. We can then talk about the angles formed. We had 2 special triangles we talked about on, I think, day 2. So if this is a 45, 45, 90 triangle, then our side lengths were x, x, and root 2x. So at 45 degrees, if this is instead multiplying everything everything so that this is 1, so everything divide by 1 over, or just divide by square root of 2. I get x, because I want everything here to have a length of 1. We're talking about the unit circle, so everything will have a length of 1. Also be 1 over root 2, 1 over root 2. One thing that we may or may not remember from algebra is how to rationalize something like this. 1 over the square root of 2 is equal to 1 over the square root of 2 times root 2 over root 2. Why is this true? What is this right part equal to? What is anything times 1? Same thing. So all I've done is I've multiplied by 1. I haven't changed the value. 1 times root 2 is root 2. Root 2 times root 2 is 2. So instead of writing 1 over root 2, we will always write root 2 over 2. We want to have rationalized denominators. That's just a convention. So this means that our triangle here actually has side lengths 1, root 2 over 2, root 2 over 2. Which means that if I think about this in terms of coordinates, its x value is root 2 over 2, and its y value is root 2 over 2. That means I can get the sine, cosine, and tangent values all right there. Another one that we had was our 60, 30, 90 triangle. We said that if this was x, this was 2x, this is the square root of 3 times x. So divide everything by 2 so that this is 1. I get 1/2, square root of 3 over 2, and 1. So for my angle of 60 degrees, I get my coordinates. My x value is 1/2. My y value is root 3 over 2. 30 degrees is just if I take and flip this. 30 and 60. Then this is 1. This 1/2 goes over here. This root 3 over 2 goes here. So the coordinate values are just flipped there. This is root 3 over 2, 1/2. The coordinate of this point, since my radius is 1, my x value, I've gone over 1, and my y value hasn't changed, so it's 0. And then again, radius is 1, so my y value here is 1, and my x value hasn't changed. This pattern then follows across the entire circle. But in general, I'll put my degree, then radian, then coordinate. And I'll make a little table for you. Degrees go 0, 30, 60, oh, I missed 45. 45, 60, 90. I go 0, pi over 6, pi over 4, pi over 3, pi over 2. We skip pi over 5 because it doesn't actually have really nice identities at all. Then my coordinates are pretty simple once I figure out the pattern. My x is 1, 0. Y, I flip that down to 0, 1. 1 is equal to 2 over 2, which is the square root of 4 over 2. I'm then just going to go down. Root 3 over 2, root 2 over 2, root 1 over 2, and then back the other way. Root 3 over 2, root 2 over 2, root 1 over 2, back to 0. And an important thing to note is the square root of 1 over 2 is just 1 over 2. So I don't need these square root symbols. And that's all those coordinate points that I just derived. Having to use special triangle trig, I could just write them all down essentially. You'll come to learn these very well. I'm not expecting you to know them now, but this is just where this table of values comes from. We then might want to derive our sine and cosine values, or maybe sine, cosine, and tangent. Sine, cosine, tangent. Again, you don't have to have this all memorized right now. When we go to do unit circle, we'll be a lot more in-depth with this, but this is just more so foreshadowing. Sine is the y value of our coordinate. Remember we talked about sine as y over radius? Since radius is 1 here, I get y over 1, so I just get y. So sine is 0, 1/2, root 2 over 2, root 3 over 2, and 1. Cosine is in the x value, 1, root 3 over 2, root 2 over 2, 1/2, and 0. Then tangent is sine over cosine. That's a useful thing to remember. I think we've discussed this at some point. Zero divided by 1 is 0. 1/2 divided by root 3 over 2 is root 3 over 3. You could work that one out. Root 2 over 2 divided by root 2 over 2 is 1. Root 3 over 2 divided by 1/2 is the same thing as multiplied by 2, so I just get root 3. And 1 divided by 0 is undefined. So for the first quadrant of the unit circle, these are all of our important identities here. That's all the degree values, the related radian values, the coordinate of that point, sine, cosine, and tangent of that point. And then on your test, I will probably give you this guide that has all of those values essentially. I'll probably make something closer to that if you want it, just because I'm not necessarily concerned about you deriving those or anything, it's more the concepts. Yes?
If I happen to change the increments, like on that it has a change of
30, 15, 30, 30.
yeah.
30, 15, or 30, 15, 15, 30. You could, but the numbers are nowhere near as nice. There are formulas for how to derive these for any general angle. It's pretty gross though. So that's why we pick these. Sometimes you'll also see they'll squeeze a 15 in here, and they'll squeeze 75 in here. Those are a lot less common, but they're sometimes useful. That's pi over 8 and 3 pi over 8, or 5 pi over 8, 3 pi over 8. So that's where you might squeeze some of those in, but these are the only ones you really need. If you wanted to, you could go through and create your own table, but these values are not going to be anywhere near as nice. So that's the caveat there. Any other questions about anything? Again, this was just some foreshadowing because I was done like 15 minutes ago and didn't want to end class 15 minutes early, even though I could have. That would have been nice. But this is just kind of foreshadowing for what we're going to do. All right. Tomorrow we will be doing test review, and let's see. Our test is scheduled for the 1st. I believe it's Tuesday. I believe that's Tuesday. So make sure to be here Tuesday.
I have a game.
Oh, well, we'll figure it out. Otherwise, that's all I have for y'all. Have a great rest of y'all's day.